Hi everyone, in this problem we're going to find the domain of this function. So if we just had log base 6 of x and we were looking for the domain, then x would be greater than 0. We just memorize that. So here we have log base 6 of all of this. So in order to find the domain, this whole thing here has to be positive, right? We can only take the log of positive numbers, so the log of all of this must be a positive number. So step one when finding the domain for logarithmic functions is to take whatever's inside the log and set it greater than 0. So 2x squared minus 7x minus 4, and we'll set that greater than 0. Okay, let's do this by using something called the test point method. It'll be a good refresher on the method. I won't write all the steps down, but I'll say them in words and hopefully it comes back. So step one in the test point method is to make sure you have a single term on one side and 0 on the other. So we don't quite have that. That means we have to try to factor this. So let's try. So this is 2x, parentheses, parentheses, and then this is x. And so the numbers need to multiply to 4. So I am thinking maybe let's try 1 and 4. So I'll put a 4 here and a 1 here. And again, I'm just using guesswork here. So one of these has to be negative. What if we do this? I'm just guessing to see if it works. Let's check. So if you do 1 times x, that gives us x. And if you do 2x times negative 4, that gives us negative 8x. Negative 8x plus x is negative 7x. Pure luck. 1 times negative 4 is negative 4. Amazing. Okay, I didn't think it would be so easy. It's just luck. Sometimes what happens if you don't do it right, just switch them up and just keep trying until you get it. This one wasn't too bad. The second step in the test point method is to take each of these factors and set it equal to 0. So 2x plus 1 equals 0, and x minus 4 equals 0. And the reason we do this is because we're looking for the places where this expression might possibly change sign. So it's not an algebraic move, right? This is just one of the steps in the method. So you factor, then you set each piece equal to 0. Subtract 1, divide by 2, it'll give you x equals negative 1/2. Add 4, you get 4. Okay, so now you're going to see why it's called the test point method, because in the next step, we actually just take these numbers and we put them on a number line. So here's negative 1/2, and then over here you put your 4. And just pick the easiest number in the world, 0. So let's check 0. So you take the 0 and you plug it into this one or this one. I'll use this one. So you would get 2 times 0 plus 1 times 0 minus 4. And we want to see if this is greater than 0. So it's 1 times negative 4. We want to see if this is greater than 0. So negative 4 greater than 0. No, it's not correct. So it's false. So here's the cheap trick. Because we picked a 0 from here, where my cursor is, right between these numbers, and it's false, we shade in the other spots, okay? If it was true, you would shade in the middle, okay? Like if it was like 2 bigger than 0, that's true, we would shade here. If it's not true, you shade in the other spots. This always works, okay, when you have a quadratic like this and it's simple. If I have something like x plus 1 squared, x minus 3, it won't work because of the 2. But whenever you have stuff like this, it works. And now we're done. Now we have the answer. Because we have a greater than, right, we're not including numbers. So we have parentheses. And then from the picture, we can get the answer. So it would be negative infinity to negative 1/2. So negative infinity to negative 1/2. Union, and then 4 to infinity. So 4 to infinity. And that would be the domain of this logarithmic function. A much, much harder problem. Like if you're taking an algebra class, you may or may not see a problem this tough. It's the pre-calc level, I think. Hard algebra, pre-calc level type problem. I hope this video has been helpful to you. Good luck.